With a rising population and growing urbanization, humans are more dependent on energy than ever before. The presence of carbon dioxide in our atmosphere is rapidly increasing, and so are its effects on our planet. The environmental consequences are being felt all over the globe and are devastating. From the rise of unprecedented hurricanes to the accelerating melt of the North Pole, there is no doubt that if we continue with these emissions, our planet will significantly suffer. Numerous organizations and governments have set out goals of reducing emissions in order to counteract the growing environmental effects. And with almost a quarter of emissions being traced back to residential heating, the challenge of decarbonizing heat is clear. Heating emissions must be minimized for a brighter, more sustainable future. At EcoTowers Residential, we aim to reduce domestic heating emissions. This would fundamentally change the way we produce and use heating. Major cities could be transformed into being greener and more environmentally friendly through the utilization of renewable energy. Therefore, our company is proposing a heating system that is capable of reducing as high as 75% of the emissions. We specialize in supplying and constructing novel ground source heat pumps to residential apartment complexes. Ground source heat pumps can be used to provide space and domestic water heating and space cooling. Our team considered all design aspects, from the source of heating underground all the way to the modern underfloor heating in the apartments. A geological survey has been conducted to identify the optimum location for our proposed heating system. As a result, Nottingham was selected due to the optimal geological factors such as soil temperature, thermal diffusivity, and conductivity of the rocks underground. Also, there are currently 3 major apartment towers in Nottingham, and according to the Nottingham City Council, there is a demand for new residential buildings. A closed-loop configuration is chosen for the geothermal heating, where heat is exchanged from an indirect circulation system. In the first phase of construction, vertical boreholes will be drilled up to the depth of 250 meters, where each is comprised of high-density polyethylene pipe containing a circulating fluid, which is pumped around in a loop. Vertical collectors are installed because of their lower pipe and pumping energy compared to the horizontal design, as well as their high thermal efficiency. Each borehole will be at least 6 meters apart to prevent thermal linkage and efficiency loss. The borehole will be 40 mm in diameter loop and are filled with grout to ensure maximum heat transfer from the ground to the fluid in the pipe. The pipes are then joined together via an underground manifold. The pipe loop then feeds into a heat pump where energy is transferred indirectly via a heat exchanger. The first heat exchanger is called the evaporator. When the fluid enters the evaporator, the energy is transferred to a refrigerant which begins to boil and turns into a gas. The evaporator gas is then fed into a compressor where the pressure is increased, thus increasing the temperature of the gas. The hot gas then flows into a second heat exchanger called the condenser. The condenser then delivers hot water to serve the heating system. Next, the pipes will rise vertically carrying the service fluid from the basement through the building and into each apartment. The fluid will be fed into a modern underfloor heating system installed in newly built, well-insulated apartments. Such a heating system provides several advantages over the traditional radiator heaters. It offers maximum comfort to the residents, in which heat is distributed evenly and consistently throughout the apartment. Also, the operating temperatures are relatively lower, thus reducing the overall heat loss and energy consumption. Finally, they take up virtually no space, since the system is integrated within the apartment floor. The system adheres to the Microgeneration Certification Scheme compliance and is eligible for a non-domestic renewable heat incentive, in which regular payments are provided by the government to subsidize renewable technologies. By carrying out the economics of the project in terms of the total costs and savings associated with our heating system, we can deduce that in fact the system is feasible with and without the support of the RHI. The figure presents the profitability of the project where 2 scenarios are constructed for the cases with and without the RHI, thus obtaining payback times of about 3.8 and 10.6 years respectively. To conclude, the project presents the consumer, investor, and the environment with various benefits, including reduced heating costs, reduced carbon emissions, a safer heating system, high feasibility with payback time as short as 3.8 years, reliable and robust heating system that lasts up to 20 years. At Echo Towers Residential, we are keen to provide renewable heating solutions for a better future.